Hey boys and girls, welcome back to Fastware. So we are celebrating 200 subscribers, yay! So anyway, thank you all for stroking my ego. I really appreciate it. It's really nice that you watch, comment. I read all your comments, try to answer them as well. Everybody who engaged, helped share my videos. I think, as you undoubtedly know, that performance engineering is a very important topic and it's often overlooked. So anybody who helps share and or become part of a community, I really appreciate that. So normally here we would jump into some sort of a topic where we would analyze a software system, its performance and whatnot. But I thought we will do something slightly different today. So on my YouTube kind of a feed, I found a video from TiffInTech about the harsh kind of a truth about software engineering, programming, and things that people don't talk about. And I found it intriguing. So one of her points that she made was that a 1-month course or a boot camp will not teach you to be an excellent programmer. And I have to agree with that. So on the side note, if you actually see those ads of within 1 month, you will get a 6-figure salary run other direction. It's a complete scam, in my opinion, personally. But I have to say that I went to a traditional university, have a CS degree, and that didn't teach me how to be an amazing coder either. So not to say what you can't do and how you can't get information, I thought to actually give you tips of what I do to actually learn new things and to be better at my job, right? So one of these things is actually a 30-minute practice a day. So you practice and you practice and you practice. Now, most of the people don't know how to practice, so let me tell you what I do. So I pick a topic, something that I know is doable, probably not in half an hour. That currently, if I would need to think about it, I can probably do in a couple hours or maybe 3. Then what I do is every day you try to solve that same problem. And first day you don't get anywhere close. Then you analyze, you think, so I could have done this better, that better. I improved there and there. And then you start it again. And from the beginning, you throw away from a previous day, you delete the source code that you've written, and then you do it the second time, and then the next time, and the next time. Then within a few weeks, maybe a month, you become so proficient at solving this particular problem so well that you can do it in that half an hour, and you can do it very well. Very important when you do this to have some sort of a goals, what your program should do, how it should perform, what is the efficiency characteristics of it, what's the scale scope. All of it is very important. So set it up and practice. And then once you've done with one, start another one. So this type of practice gives you something that no amount of work or going to job, learning on the job would give you. And that's basically an intuitive sense for sensible defaults, right? It's kind of a muscle memory how to solve problems well, right? So one of the things that I kind of learned, one of my sensible defaults are many by default, which means that functions, instead of taking like an object on as a single argument, it takes an array of these and transforms all of them together, right? So I found it that the performance of your applications, especially when a compiler cannot inline your functions, are much better this way than doing in any other way. And also things like SIMD vectorization can kick in. So there's a lot of potential benefits in doing it this way. Now, building on top of that, the second sort of a recommendation, or what I've learned, is that functions that transform data must be fully deterministic, meaning that no matter what happens to the global or local state, that it could not affect the outcome of that function. And that kind of goes in a face of object-oriented programming. The reason for it is because member functions of a class implicitly affect or read a state that can be affected by something else. And this is, in my opinion, not a great design pattern, and therefore can cause many more problems than it actually solves. So generally, if you write fully deterministic functions, that kind of a philosophy enables you to write actually testable and scalable programs in general, right? So to conclude, I generally avoid object-oriented programming, and I needed to unlearn what I was taught at university by actually practicing in this sort of a problem-solving thing. And you should do exactly the same. Find your own reasonable defaults that will enable you to solve complex problems in a fast, scalable, maintainable, and well-performing fashion. So that would be what I would do. Now, another topic Tiff touched on is about learning multiple programming languages. So as an engineer, you will have to know more than one programming language, and nobody can argue with that. I will start with a little anecdote. So at the university, I was actually taught Java, but now I firmly stand that this was actually a disservice to me and to other students. It might be controversial, but I would argue that you should start by learning lower level languages first at the university level. I don't mean like at school or when you self-taught, but at university level, they should start teaching lower level languages first. Now, the argument is actually simple, that lower level languages like C or C++ expose you to software hardware duality and their interactions. The experience and understanding gained from that enables you to solve problems in a vastly different way. And there is a bonus of knowing how hardware runs and interacts with your software makes learning new languages actually almost trivial. Is because if you grasp the fundamentals, that basically you understand how software does what it does. So different languages just repackaging of exactly the same ideas, and it becomes very intuitive. There's just so many ways you can get from that set of input with that operation to that set of output, and so it becomes a window dressing. It's not particularly important, and you can, if you know these fundamentals, you can pick up any other programming language fairly easily and without any problems. Now, I will skip the rest of the points that Tiff made. She made them well, and you can, of course, watch her making those videos. So the link to her video will be in the description below. Check it out. But I would like to add one of my own harsh truths. And that would be that most issues you will encounter as an engineer are not going to be due to code, generally speaking. But instead, it's going to be with people. So with environment, with people, with your colleagues. So it's going to be fairly difficult, as the teams that you're going to be working in generally are not on the same page. They don't have the same experience. They don't value the same things. They have a completely different understanding of problems and whatnot. So I would say more than half of the time that you will be spending will be actually in discussing, explaining, demonstrating, or trying to convince of some specific solution to the problem or general engineering approach or concept. And these sort of disagreements are not free. They can prevent code merges, sometimes even forcing release delays, and no doubtably some inquisitive managers asking you are like, why are you doing it differently? Why are you not like everybody else? That question is sort of funny to me, because what they really actually mean is why you are not a corporate tool, why you don't follow the instructions and do what we tell you to do. But I don't want to be all doom and gloom. So, but yeah, in my experience, I believe that there are only very few organizations that actually encourage diversity of thought, diversity of approach, and reward creative problem solving. While most of them are actually like black holes, attracting, you know, aspiring software engineers with good salaries, promises, and whatnot, and then squashing their creativity, generally speaking, and reducing them to I need that paycheck, so I'm gonna come in and do what I'm told. So, in other words, a corporate tool, and that's where creativity goes to die. At many of the large corporations, there is nothing creative that happened there in generations, most likely. So if you're still watching, I would like to thank you for that view. I would like to encourage you to subscribe if you haven't. That would help me a lot. If you disagree with my take here, so leave the comment, tell me why. If you agree, let me know what maybe I could improve. Leave that like or dislike. And as always, have fun writing fast code. Cheers. Bye.